We're going to do some examples for matrix algebra. Our first example, we have two matrices, and we want to add them together. So the first one, we're scaling by 5. Oh man, we can add these matrices because they have the same dimension, 3 by 2. If they don't have the same dimensions, then you can't add them together. So first thing we do is we multiply these two together, or we multiply 5 through, so we get 10, 20, 30 for this column, and then the second column we get 15, 25, 35. And this is still being added to 7, 5, 3, 1, 0, negative 1. And then adding these together, we get 17, 20, 23, 26, 30, and 34. And that's it. That's the sum of those two matrices. Our next example is some matrix multiplication. So first we gotta see if matrix multiplication is defined. We do that by writing down the dimensions of the matrix. So actually, this is 2 by 3 matrix. So we have 2 rows, 3 columns, and then this matrix here is 3 by 1. So if these match, then the multiplication is defined, and our output will be whatever numbers are left, so it'll be 2 by 1. So let's go ahead and multiply these. So we know it'll be 2 by 1, so it's going to have 2 rows and 1 column. So our first entry will be the dot product of this row and this column. And that'll be negative 1 times 1, which is negative 1, plus 2 times 2, plus 3 times 1, and the row beneath will be dot product of these two, this row and this column. So that'll be negative 1 times 2, plus 2 times 3, plus 1 times 4. And then this will equal negative 1 plus 4 plus 3. This will be negative 2 plus 6 plus 4. And the answer, doing this addition, would be 6 and 8. Okay, our third example is another matrix multiplication example. So the dimension of this one is 2 by 3, and the dimension of this one is 2 by 1. And since these don't match, matrix multiplication is not defined. Can't multiply this, and like it makes sense because we try doing the dot product between these two this column and that row. We get 7 times 1, and then 6 times 2, and then nothing to multiply or 3 by. So it doesn't make sense to have multiplication in this case.